This is the second half of chapter 8. Instead of putting polynomials together, we are now breaking them apart, and today is the first lesson of the second half of this chapter. We're going to factor a polynomial using what's called the GCF, or the greatest common factor. I'm sure you've heard it before. For example, what is a factor? It's any of the numbers or symbols in mathematics that when multiplied together form a product. So 2 and 3 would be factors of 6. It says for the following terms, what is the greatest common factor? So 18 and 9, they have 3 in common, but what is the greatest common factor? Your answer would be 9. Some of you can just see this, but if you can't, what you're going to do is you're going to take each term and you're going to break it down into prime factors. So what do they have in common? This 3. What do they have in common? This other 3. So what do they have in common? 3 times 3, which is 9. Same thing here. We can see they all share a 5. We can see they all share one x. If you can't see it, then you need to break each piece down into prime factors. And then you tell yourself, okay, they all have a 5. They all have an x. So what they share is 5x. 22 and 11. They share an 11. They also share only one y. So if you break 22xy down, it's 2 times 11 times x times y. And they only share an 11, and they only share a y. Here, the GCF, what they have in common is a 3. What they have in common is an x. And what they have in, they don't have a y. So if you can't see that, you need to break these ones down as well. Feel free to pause the video if I'm going too fast. So they all have a 3, all have an x. That's it. Okay, if you keep going, try pausing the video and doing these two on your own. Okay, now looking at these, it says identify each polynomial as prime or not prime. Prime means, okay, that there's only a GCF of 1 between all the terms. Not prime means there is a GCF between them all. So is there a number that 9, 24, and 15 share? Yes, 3. So we're going to say that it is not prime. Same with 9m squared plus 16. They don't share anything, so it is prime. Kind of went out of order. I'm going by columns. Here they all have a 2, so it's not prime. Think about prime numbers. 7 is a prime number. 7 and 1. 13 is a prime number. They share an A. They share a 3, so it's not prime. They don't share anything besides 1, so it's prime. Same with the last. You think they would share something, but they don't. Okay. It says let's factor the polynomials by using the GCF. So what do these two have in common? They have a 2 and an x in common. Therefore, I'm going to factor, break apart. If I asked you to factor 50, for just a random example, you could say, oh, it's 5 times 10. You wouldn't just write 5 down. You'd write 5 and 10. So same thing. All these have a 2x, but what remains in the parentheses? We're going to use the distributive property. We're going to factor. We're undistributing. So if I remove a 2x from each term, 8 divided by 2 is 4x plus anything divided by itself is 1. So this is your answer. Saying this was the after, this was the before. 2x times 4x is 8x squared. 2x times 1 is 2x. That's it. You can check your work by distributing. Here, what do they have in common? They're GCF. The number is 7. How many x is just 1? So it's going to be 7x times what gave you this result. So if I remove a 7x from each term, what remains? X squared minus 3x plus 2. Go back and distribute to see if you did it correctly. 7x cubed minus 21x squared plus 14x. Done. There's going to be a purpose to factoring, but we're going to wait a few days to explain why. But first, we have to have the skill and drill down of doing this before I do that. Here, your GCF is 3. So if I pull the 3, I'm left with, okay, 8 goes into, or 3 goes into 8 once. Actually, it goes in twice. So you're left 6, 2, 1, 7. So it's 27 y squared plus y minus 3. Go back to distribute to check. 81, 3y, 9. It's done. Here, all they share is an m. So we remove an m, and what are you left with? 3m squared, 10m minus 1. Careful, people just want to cancel out. And as teachers, we say that, but we shouldn't. It simplifies to 1. Okay. Now they want you to factor using the GCF. So take your time. I want you to pause, okay, and watch the video. If you're like, this was super easy, do it how I did it. But what I would do if you're having a hard time is just go through and find the GCF of each. Okay, so here they both share 3x. What's left over? Here they all share 3. Here they all share a 9. I see an x and I see a y in each. Your GCF here, I don't see any numbers, but there's variables. Same with this 3 and this q. 3, does 3 go into 14? 3 times 3, 4, goes in 4 times. Yep, it can go in. So a 3v squared. And then here they all share a 5, a w, and a z. All right, so x is left over. And when I remove a 3x from each piece, what is left over? Just a 3. I remove an r from each. What's left over? 6r squared plus 3r minus 7. I remove a 3 from each. What's left over? 2 w to the 4th w squared minus 3. I remove a 3q from each. And I have q, 2, q to the 4th, plus just 3. The q simplify. Right. And if you're watching this video while you're in class, okay, or if you're at home, you can ask me the next day. But if you're in class, stop the video and come over and ask me. Divided by 9, if you need assistance or anything. 2b cubed minus 4b squared minus 1. Here, they all have a 3b squared. So it's b to the 4th minus 3b squared plus how many times does 3 go into 1? It doesn't. How many times does 3 go into 14? Well, 4. 4 times 3 is 12. Subtract the 2, 27. We're left with 9. The v's simplify. Sorry for all the noise. I do have kids in here. See you, travelers. Divide by xy, xy, xy. You're going to get a 1 minus 2x y squared. Here, you're going to have 2z minus 1. Okay, and that's part 1. Part 2 of factoring the GCF is sometimes we don't have a common number between things. We have a giant quantity that they share. It says you might get a polynomial that looks like this, and this is just an unsimplified form of a polynomial. So looking at each piece, this is one term, and this is the other term. And what's their GCF? What do they have in common? This entire quantity. Therefore, their GCF is x plus 1. I remove it. And when we factor that out, what's left over? X plus 2. And that's it. Okay, so using that process, let's identify the GCFs on this page and factor. We have a y plus 1. So we're left with a y plus 2. We have a c plus d. So we're left with a 3 minus a. They both share an x plus 4. So we're left with a 3x minus 2. They both share an x plus 2. So when I remove it or divide it out, technically there's a 1 here. So it's x minus 1. So I want you to go ahead, pause the video, and try to do the next ones. Some kids just write 7x, but when you divide something by itself, it's 1. Careful. Also here, you could rewrite this as a minus b squared. It's the same thing twice. Why do I do this for some and not the others? Because I have mn, and then this disappears, so it helps me to write underneath minus 1. Okay. In your homework, you're not going to get them looking like this per se. You might get y squared plus y plus 2y plus 1. Your goal is to get this to look at like this so you can go like this. So if you have 4 terms, we're going to use this method called grouping. And what you're going to do is say, okay, I have a GCF between these two, and I have a GCF between this two. Overall, I don't have a GCF. I could put these together, but it's not going to do me any good. I see between these two, I have a y. So I'm going to pull that y out and have y plus 1. I see between these two, oops, it should have been 2. I see between these two, I have a 2. So I take out a positive 2, and I'm left with y plus 1. Then it's going to look like this, where I say, okay, now I have a GCF of y plus 1. And when I remove it, I'm left with y plus 2. So if you look again, let's try something like 3c plus 3d minus ac plus, minus ad. Overall, they share nothing. But between these two, they share a 3. So I'm left with a c plus d. I want to see c plus d again, or I did grouping wrong. So do I take out a positive a or a negative a? If I take out the negative a, I'm left with a positive C. Good. It was minus, so now it's going to become plus. And that's what I want. There's a GCF between the two, C plus D. And I'm left with 3 minus A. So that's what you're going to have to do in your homework is start from here to get to here. And then you have these.